Hello, geometry. We have a quiz tomorrow. It will be on sections 2.3, 2.4, and 2.5. 3 questions from each section and one extra one from one of them. Okay, and as I look through this organizer, the first thing I noticed is there's a few new questions. Second thing I noticed was after the video I made last week, not everything has been updated like I did this one last week, and it's still right there. Terry's question, I still don't know what it's about. So guys, you got to update the organizer. This is all I have to go off of. But even if I didn't, you're still supposed to update it. Okay, and let's make sure that we know for a red problem. Now I know there's no hints in the textbook, but you can put class or just put as much of the problem as you are able. Let's add that. Oh, not the problem, but the problem solution as you are able. Even if it's wrong, just give me something. The more you can tell me, the better I can help you. Otherwise, I just got to start at step 1, and that's okay if that's where we are. But let's look at this first one together now. I didn't try to solve this before I started this video, so if I get stuck, then I'm just going to pause it. But as you know, I love to just let you think with me, and I don't mind being stuck in front of you, because in math, when we're real mathematicians, sometimes we get stuck. And it's not a question of when, but what are you going to do when it happens? All right, roofs are designed based on the materials used to ensure that water does not leak into the buildings they cover. Some roofs are constructed from waterproof material and others for watershed or gravity removal of water. Pitch of the roof is the rise over run. Hey, know about that? Circle that. Rise over run, you mean the slope. Annotating this question a little, which is generally measured in rise per foot. Rise per foot of run. Use the statement below to write a paragraph proof justifying the following statement. The pitch of the roof in Den's design is not steep enough. Well, as I said, we're not doing paragraph proofs on the quiz, but we are just the postulates. But still, let's look at this question. So waterproof roofs should have a minimum slope of 1/4 inch per foot. Watershed roofs should have a minimum slope of 4 inches per foot. Dan is designing a house with a watershed roof. The pitch in Dan's design is 2 inches per foot. Okay, so Dan is a person designing a house with a watershed roof. And so the information about watershed has got to have a minimum slope of 4 inches. But Dan's design is 2 inches. That is less than the minimum. And the statement is the pitch of the roof in Dan's design is not steep enough. So you just show you how this would look with the statements and reasons. So given Dan has a 2 inch per foot pitch watershed. So reason that was given. But now we know that watershed pitch, that's not how you spell watershed. Watershed pitch. Watershed pitch should be greater than or equal to 4 This is the reason is that is the watershed requirement, right? That is the standards, right? And so 2 is less than 4, and that is just, inequality. I mean, it's just the inequality. And so because 2 is less than 4, then Den's design, oh no, isn't steep enough. Sorry, buddy, your design is not steep enough. Okay, so I just had to read through it and think about it. But when I saw those requirements, it became pretty clear. So Terry, go ahead and explain in your own words the solution or a solution above for questions you still have based on the solution. So I understand what you did this, Mr. Field, but not this. Let's have a conversation in the document, and other people can also be involved, as I know you guys already know. All right, Nana, update the organizer. Terry, update that organizer. Tariq, update this organizer. Michael, update the organizer. Daniela, this one we do have to do. Again, I have not tried to solve this problem yet, so let's think through it together. Yay. All right. Gotta give myself some more space here. All right, networks. Diego, oh, I know Diego, it's Dora's cousin. Diego is setting up a network of multiple computers so that each computer is connected to every other. The diagram at the right illustrates this network if Diego has 5 computers. Draw diagrams of the network if Diego has 2, 3, 4, or 6 computers. Okay, create a table with the number of computers and the number of connections for the diagrams you drew. If there are n computers in the network, write an expression for the computers which is connected. If there are n computers in the network, write an expression for the number of connections there are. Oh man, this is a doozy, isn't it? All right, let's do it. This is a good question. All right, so why don't you guys pause this video and try for yourself, okay, before you make do all this work. All right, so at 10:20 at night. Okay, so 5 computers connections. Yeah, 5, and there are 1, 2, 3, 1, 2, 3, 4, 5. No, I'm having trouble. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 connections. Wow. Hopefully it's just that simple. Hopefully it's 4, 8, 3, 6, 2, 4. I don't know. Now I can't imagine it's 2, 4. These are just guesses. All right. So let's see. Again, 2 is just 1, right? Okay, so 2 computers. So I'm going to draw a picture. The first thing is in geometry, we draw a picture, and it says that's A anyway. Draw a diagram. So we got computer B, And to connect both of them, it takes 1. So unfortunately, the doubling, my conjecture was false. But I'm trying, you know. All right, so this is the 2. Now how about the 3, the triangle? 1, 2, 3. So 3 was 3. And then how about the 4? Well, that's 1, 2, 3, 4, 5, 6. Okay. 6. And then we gotta do 6. All right, so then that 6 is a hexagon. This is a hexagon. 1, 2, 3, 4, 5, 6. All right. So A, B, C, D, E, F. Right? So there's already 6 there because of the sides. And then let's see. Maybe we got 1, 2, 3. So then plus 3 from A. And then going to B, now I got to connect what I can't. So 1, 2, 3. Sorry, connected to C, right? And then from C, we got that one, I got that one. I can go to F1, 2, and then from D, oh, no, I can't see nothing. All right, so let's see. 12, 13, 14. So I don't know if I messed up that 6. It got pretty hard to see. What if I Google hexagon? Oh my gosh, it came up. Empowering an autonomous future. The world. I just want a hexagon. All right. So, all right. So now I got some. So we're gonna try this one more time because we gotta be able to see and make sure that 14 is right, or everything's gonna be out of sync. Okay. So first of all, 1, 2, 3, and that's it, right? And then B was 1, 2, 3. So that was like that, wasn't it? And then C was 1, 2, and then D. I can't go to B already, C already, A already. Oh, 1 for F, and then E already. Did I have that? 1. And then E is already D, C, B, A, F, and then F is already connected to everything. So I was wrong. So it's 15. That was helpful. Okay, so 1, 3, 6, 10, 15. So it's going up by 2, up by 3, up by 4. Aha, up by 5. Pattern. So this is B right here. A table with the number of computers and the number of connections. All right. So there's A, and there's B. Let me just screenshot that first part there, my face here. Okay, it's for you, Daniela. All right, now I'm gonna clear it. Okay, so if there are n computers in the network, write an expression for the number of computers to which each is connected. Okay, Can we do that? So let's write that table again. It was 2, 1, 3, what was it? 2, 1, 3, 3, 4, so increase by 2, 4, 6, 5, 10, 6, 15. Okay, so now there's n computers, write an expression for the number of computers to which each, so if there's n, it's going to be 1 more now. If there are n computers in the network, write an expression for the number of connections there are. There are n computers in the network, write an expression for the number of computers to which each of the computers is connected. All right. We're going to go ahead and we're just going to take these off the quiz for now. Field starts to think about that a little more, but the reason that I'm taking it off is because it's kind of getting away from our postulates. And so A and B could be on the quiz, but hey, C and D could not. And you know how you know it? Because you asked about it. So there you go. Sorry, it's not a cop-out. Just buying myself some time. Not dun, dun, dun. All right. Meanwhile, I will. Now, see, look, here's a picture of a wedding cake and lots of red lines. That's it. I see Usman has that in green. So Usman, Jaden, maybe you could talk, but Jaden, I don't know why that's there. Christian, you're right. It looked complex to me too, buddy. But we do need to say a little bit more about the problem than that. Or I just might sign out of the organizer. Okay, hopefully we'll sign back in here momentarily. Maybe I won't sign back in. Hold on, let me pause this. All right, and we're back. Okay. So, what is it? I don't see the question, just the explanation. Okay, aha, Gabriel, and that's it. And that's all the red problems. So, guys, you can ask more red questions than that, because what's happening is, like I said on the phone the other day, I'm giving you all the problems that can be on the quiz are already at your disposal. If you're a college kid with that kind of information, I mean, whew, be good to go. But you guys got to get used to it. So it's not going to stay like that either. I'm going to make it a little bit more tough by changing the questions a little bit, and then so you'll have all the basic ideas. But for now, you have all the exact questions. So let's see if we can get past this first hurdle. Load up the red section. And you guys on Thursday were assigned every question in section 2.5. So did you put any new red questions after you tried them? Or do you still say, no, I understand everything perfectly? Or do you say, I'm completely lost? But I saw some people that said they were completely lost on the textbook organizer, but I haven't went over any of their red questions. So are you just going to be completely lost and then that's it? Or do you want to ask me some questions? Come on now. Don't just whine and complain. All right, get to work. In the figure at the right, AE, segment AE is congruent to segment DB, and C is the midpoint of segment AE. And segment DB. Write a paragraph proof to show that AC equals CB. So again, we're not doing paragraph proofs, but let me just show you a 2-column proof, the statements and the reasons. So in the figure at the right, AE is congruent to DB. So we can write that. AE is congruent to DB. It's given. First reason is always given. Okay. And C is the midpoint. Oh, wow. A lot of give. C is midpoint of AE and DB. Is that right? So that's also given. So right, show that AC equals CB. Okay, so now when we're writing proofs, so what we do is we look for a keyword in the statement. And then that gives us a clue to the following reason. But what's the keyword in this statement? Someone raise your hand and share out. Did you say midpoint? That was correct, midpoint. And so guess what? Our third reason, because that's the keyword, is going to be definition of midpoint. And you should know the definition of midpoint because it's been in a previous section. The definition of midpoint is that the two segments on either side are congruent. So AC is congruent to CE. And also DC is congruent to CB. Now I can use one hash mark for each because I already know that the segments are congruent. So, we have that. And so now we can say, like AC, because now we could say, well, we could say that all right, I can say like this: AC plus CE equals AE. You know what that is? That's the segment addition postulate. Remember that? But also, because AE is congruent to DB, I can say AC plus CE equals DB. And that is substitution. All right, and now I want to show that AC is congruent to CB. So right here I have AC, and now I need CB. I'm gonna have to write another inequality. Or equality. DC, so DC plus CB equals DB. That is also the segment addition postulate, and also substitution would be DC plus CB equals, well, now hold on here. Hold on here. What we could do is we can say, so do I have the same thing? Let me just go ahead and pause this for a second. All right, so I took some time to think about it. Hey, you could see the time. You see how long it took. So when you're writing a proof, sometimes you gotta back it up and you gotta retry. So, but you gotta start by trying, just like I did, and then think it through. And then if you get stuck, that's okay. That's part of the proving process. So I'm gonna back it up a little bit. And I'm going to stop at the segment addition postulate here. But we know that we have the, now I might have to pause it again, but I think I have an idea here. So the thing that I forgot to say was, C is the midpoint. So that means C being the midpoint means AC equals CE, right? And also DB equals CB. And I eventually want to say AC, this one, and CB, this one. And so if I can just write an equation with AC and CB and just skip these two that I don't need, then that would be good. And I already know, we know that AE equals DB. So we can use that. Okay, so I know AE is AC plus CE, right? But AC is equal to CE. So I can rewrite this as AC plus AC equals AE. And that is substitution. Or just 2AC equals AE, right? And we can do the same thing. Oh, and then we can do the same thing with the other segment, the CB. So then we can write so we can write we can write DC plus CB equals DB. And then we don't want the DB, we want just the CB. So we're going to replace the DB. Oh, but DC equals CB. DC equals CB. Okay, but now I would just want to write CB plus CB equals DB. Doing the same thing with this other segment, the segment addition postulate. This is substitution. All right, and now we have 2CB equals DB. All right, so 2CB equals DB. And so we could, and then we also know that 2AC equals AE, right? From step 3. But we know that DB equals AE. So we can say transitive property, 2CB equals 2AC. It's transitive property. Right? And then divide CB equals AC, division property of equality. So this was 2CB equals DB. That was combining like terms, algebra. And then 2AC equals AE. That was rewriting step somewhere, step 3. And then I just did the transitive property and voila. Okay. Will that be on the quiz? No, it will not. But I wanted to take this time to let you just go ahead and go through a proof with me. All right. It's not fun, but as we go on in the year, it'll get easier and easier, or maybe not, but maybe you'll get more familiar with it. Okay. And that is the end of this table. Now, if you wanted to post and you didn't have another row, you can just right click and add row below, or you can just press the tab button. And there. But anyway, so now with the time remaining in class, if you could create a practice quiz with 3 problems from section, what again? What am I making this quiz on? 2.3, 2.4, and 2.5. All right, and it's quiz day tomorrow, rain or shine. See you guys there.